Nuclear weapon, journey towards destruction. A threat to human life. Welcome to TechieSpod, where you get all the information on interesting topics and blogs on it to read. If you are not subscribed yet, then you are missing out something. So, here we go. Most important question that should be arising in everyone's mind is that after seeing present situation, if nuclear war happens, then what will be its consequences? What is nuclear weapon? A nuclear weapon is an explosive device that derives its destructive force from nuclear reactions, either fission bomb, or from a combination of fission and fusion reactions. Both bomb types release large quantities of energy from relatively small amounts of matter. The first test of a fission atomic bomb released an amount of energy approximately equal to 20,000 tons of TNT, 84 TJ. The first thermonuclear, hydrogen, bomb test released energy approximately equal to 10 million tons of TNT, 42 PJ. A thermonuclear weapon weighing little more than 2,400 pounds, 1,100 kg, can release energy equal to more than 1.2 million tons of TNT, 5.0 PJ. A nuclear device no larger than traditional bombs can devastate an entire city by blast, fire, and radiation. Since they are weapons of mass destruction, the proliferation of nuclear weapons is a focus of international relations policy. Who discovered nuclear weapons? A discovery by nuclear physicists in a laboratory in Berlin, Germany, in 1938 made the first atomic bomb possible, after Otto Hahn, Lise Meitner and Fritz Strassmann discovered nuclear fission. When an atom of radioactive material splits into lighter atoms, there's a sudden, powerful release of energy. The discovery of nuclear fission opened up the possibility of nuclear technologies, including weapons. Science behind nuclear weapon. Modern nuclear weapons work by combining chemical explosives, nuclear fission, and nuclear fusion. The explosives compress nuclear material, causing fission. The fission releases massive amounts of energy in the form of X-rays, which create the high temperature and pressure needed to ignite fusion. Nuclear bomb is of two types. Nuclear fission, atom bomb. When an atom splits into two parts, either through natural decay or when triggered within a lab, it releases energy. This process is known as fission. It has great potential as a source of power, but it also has a number of safety, environmental, and political concerns attached to it that can hinder its use. When a neutron strikes the nucleus of an atom of the isotopes uranium-235 or plutonium-239, it causes that nucleus to split into two fragments, each of which is a nucleus with about half the protons and neutrons of the original nucleus. In the process of splitting, a great amount of thermal energy, as well as gamma rays and two or more neutrons, is released. Under certain conditions, the escaping neutrons strike and thus fission more of the surrounding uranium nuclei, which then emit more neutrons that split still more nuclei. This series of rapidly multiplying fission culminates in a chain reaction in which nearly all the fissionable material is consumed, in the process generating the explosion of what is known as an atomic bomb. According to the study, atomic bomb has controlled reactions can be controlled if correct method used. Nuclear fusion, hydrogen bomb. It is a nuclear process, where energy is produced by smashing together light atoms. It is the opposite reaction of fission, where heavy isotopes are split apart. Fusion is the process by which the sun and other stars generate light and heat. It's most easily achieved on Earth by combining two isotopes of hydrogen, deuterium and tritium. Hydrogen is the lightest of all the elements, being made up of a single proton and an electron. Deuterium has an extra neutron in its nucleus. It can replace one of the hydrogen atoms in H20 to make what is called heavy water. Tritium has two extra neutrons, and is therefore 3 times as heavy as hydrogen. In a fusion cycle, tritium and deuterium are combined and result in the formation of helium, the next heaviest element in the periodic table, and the release of a free neutron. Which among above is more dangerous? Thermonuclear weapon is more dangerous is because nuclear fusion is held with two light nuclei and it is very difficult to stop them and hence becomes uncontrollable. So, hydrogen bomb and nuclear fusion is more dangerous than fission. Firstly, let's discuss the world's most powerful nuclear countries. United States. Deployed 1,600. Total 6,185. The United States was the first country to manufacture nuclear weapons and is the only country to have used them in combat, with the separate bombings of Hiroshima and Nagasaki in World War II. Before and during the Cold War, it conducted over 1,000 nuclear tests and tested many long-range nuclear weapons delivery systems. Russia deployed 1,600. Total, 6,500. According to the Federation of American Scientists, an organization that assesses nuclear weapons stockpiles, as of 2018, the Russian Federation possesses approximately 6,500 nuclear warheads, which is the largest number of nuclear weapons in the world. In addition to nuclear weapons, Russia declared an arsenal of 39,967 tons of chemical weapons in 1997. The Soviet Union ratified the Geneva Protocol on April 5, 1928 with reservations. The reservations were dropped on January 18, 2001. Russia is also party to the Biological Weapons Convention and the Chemical Weapons Convention. France deployed 280. Total, 300. France is one of the 5 nuclear weapons states, under the Treaty on the Non-Proliferation of Nuclear Weapons, but is not known to possess or develop any chemical or biological weapons. France was the 4th country to test an independently developed nuclear weapon in 1960, under the government of Charles de Gaulle. The French military is currently thought to retain a weapons stockpile of around 300 operational, deployed, nuclear warheads, making it the 3rd largest in the world, speaking in terms of warheads, not megatons. Nuclear attacks happened in past. Nuclear weapons have been used twice in war, both times by the United States against Japan near the end of World War II. On August 6, 1945, the U.S. Army Air Forces detonated a uranium gun-type fission bomb nicknamed Little Boy over the Japanese city of Hiroshima. 3 days later, on August 9, the U.S. Army Air Forces detonated a plutonium implosion-type fission bomb nicknamed Fat Man over the Japanese city of Nagasaki. Effect and outcome of this attack. An atomic bomb causes massive destruction through intense heat, pressure, radiation and radioactive fallout. At the hypocenter, center of the blast, the heat is so intense, it vaporizes people and buildings. Between 60,000–80,000 people were killed instantly when the bomb detonated over Hiroshima, and an estimated 140,000 died from acute effects of the bomb before the end of the year. The death toll increased to over 200,000 people in subsequent decades, as people died from cancers and other diseases linked to radiation poisoning. In addition to the human toll, almost 63% of Hiroshima's buildings were destroyed and a further 29% damaged by the bomb. The Jinbaku atomic bomb dome was the only building left standing near the hypocenter. Today, it is preserved at the Peace Memorial Park and the city has been rebuilt around it. The total death toll in Nagasaki was lower in comparison, as parts of the city were shielded by mountains. Still, at least 75,000 people died there in total. Nagasaki receives less attention in analysis of the bombings, despite being the last place a nuclear weapon was used in warfare. Hibakusha, the Japanese term for explosion-affected people, continue to campaign for Nagasaki to retain its sad distinction. In spite of the destruction caused by bombs, there is huge destruction caused by radiations. Nuclear weapons emit large amounts of thermal radiation as visible, infrared, and ultraviolet light to which the atmosphere is largely transparent. This is known as flash. The chief hazards are burns and eye injuries. On clear days, these injuries can occur well beyond blast ranges, depending on weapon yield. Fires may also be started by the initial thermal radiation, but the following high winds due to the blast wave may put out almost all such fires, unless the yield is very high, where the range of thermal effects vastly outranges blast effects, as observed from explosions in the multi-megaton range. What is radiation? The release of radiation is a phenomenon unique to nuclear explosions. There are several kinds of radiation emitted. These types include gamma, neutron, and ionizing radiation, and are emitted not only at the time of detonation, initial radiation, but also for long periods of time afterward, residual radiation. Effect of radiation on human body. Radiation poisoning, also called radiation sickness, or a creeping dose, is a form of damage to organ tissue due to excessive exposure to ionizing radiation. The term is generally used to refer to acute problems caused by a large dosage of radiation in a short period, though this also has occurred with long-term exposure to low-level radiation. Many of the symptoms of radiation poisoning occur as ionizing radiation interferes with cell division. There are numerous lethal radiation syndromes, including prodromal syndrome, bone marrow death, central nervous system death and gastrointestinal death. So, guys, this all about this topic. Don't forget to like, share and subscribe. That's all for this video. I hope you all like it. Please follow us on Instagram, Facebook and Twitter. The links for the following are given in description. Thank you.